Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of Mathematics for Plumbers and Pipefitters. My name is Thomas, and in this presentation we're going to look at Unit 9. We will be discussing copper tubing. Let's start off with this question. What is it that drives the market from one type of material to another? For example, early in plumbing we used cast iron and galvanized steel. Even for water lines it was galvanized steel. So why then, in the 60s and 70s, did it transition over to copper water lines? And copper water lines continued to be used through the 70s and 80s and into the 90s, and then in the 90s we see this transition on water lines from copper to PEX for the most part. Why did we go from copper to a plastic? Well, the answer to this question of what drives the change is it's the cost, mainly, right? Cost and availability. Early on when we had steel, there came up a need for steel in other ways. Steel was used to make different war machines during World War II and during other wars following. And there were other uses for steel, so they found an alternative. Copper is actually a really good pipe when it comes to holding water for a long period of time. So they started using it. But copper is also useful for many other things, and it is a limited commodity, so they have developed other ways of distributing water, namely PEX or other plastic. We see this on the drainage side as well. It used to be cast iron, and then it moved into ABS and PVC plastics. So this replacement of metals with plastic mainly had to do with the cost and the availability of materials. And I want you to understand that because you may come into this trade and learn a certain method and material, right? You're learning on PEX, you're gluing together PVC, but keep an open mind. There may be in the future other methods and other materials that emerge because it's a constantly changing thing. Don't get so set in a certain way that you become like plumbers that I'm aware of who wouldn't get past copper. They wouldn't use PEX. And it drove them out of the market because they could not compete with those that were using PEX and could do the work faster and cheaper. So again, my advice to you is stay up with the times. Follow the changes. Learn the new methods and the new materials. Back to copper though. Let's look at some of the uses of copper. In the book they mention specifically that copper is largely used for water lines, but it is also used in drainage, or maybe I should say was used. There are a few commercial applications that still use copper for drainage, and when you're in those situations, the plans will spec that out and it'll say, here's what you have to use, copper. But any other plumbing situation, you're not going to be using copper on drains because it is so expensive. As we examine copper, it is important to understand that there are different types of copper, and that's how we say it in the plumbing trade. It's a type. There are types K, L, M, and DWV. You can see from this illustration in the book, we're looking at an 1.25 inch pipe, nominal pipe size. Again, nominal meaning you're looking at the cutaway, you're looking at the inside diameter. Examine this closely, and what do you discover? Once again, the outside diameter of all of these pipes, all of these types of copper pipe, are the same, 1.375. But the difference between these pipes is the inside diameter. If it has a smaller inside diameter, that means it has a thicker wall. Now, why would you want a thinner or thicker wall when you're dealing with copper pipe? Well, if you're trying to go cheap or save some money, a thinner wall is going to be less expensive. So we see that on these other types where we have DWV or M. These have a much larger inside diameter, which creates a thinner wall, which means the pipe is going to cost less. L and K are going to get thicker and thicker. So why would you use one or the other? Well, this table helps us out with the understanding there. It gives us the type and then recommended for. Type K is recommended for underground or interior service. We're talking the main line, right? Coming from the street to the building. Type K is very often used by plumbers in the soft copper variety. Soft copper comes in rolls, 100 feet or so. These rolls are soft enough that you can just roll it right out. The opposite of soft copper, of course, is hard copper. This is more tempered, it's more rigid. This is what we buy in 20-foot lengths, and it's a stick. You know, you're not going to be able to bend that thing without destroying it. But again, for type K, most of the time, we're looking at rolls. We're using it on main lines. We're using it underground. Type L is most often used inside of commercial buildings. It has a good, solid, thick wall. Most of the time we buy that in the hard copper, so it comes in the sticks, we cut it up, we solder on the fittings. Type M is used for hot water heating. That means radiant or recirculating hydronic systems, drainage, waste, and vent. Over time, type M has also been used as water lines in residential. I don't know if it's specifically rated for that, but in general, as people try and build residential as cheap as possible, they have been installing type M copper in residential applications. And then finally, DWV stands for drainage, waste, and vent. Drainage, waste, and vent piping. I mean, these are larger copper sizes. You have to understand one of the differences with copper drainage, waste, and vent is not only we have a thinner wall on the pipe, but we have a difference on the fitting. Now, copper fittings have a socket, and the copper slides into the socket and you solder that in place. The socket on a drainage fitting is not as deep as a water type fitting. So that's the main difference we see with drainage fittings. Once again, very unusual that you are even going to see copper drainage pipe. As a plumber, it is important that you are able to identify the difference in these types of pipe. And to help us along, they have come up with a color code for each of these 4 types. You can look for the color on the side of the pipe. It's going to be the printing, the printed words, all of that information given, which would include the size of the pipe and the type. It says it right on it. But the color gives us a quick reference, so we don't even have to get in and look at the words, or worse, try and measure the inside diameter or something. It's color coded, okay? So let's go through the color code. The color for type K, it's going to be printed right on the side, is green. The color for type L is going to be blue or sometimes black. The color for type M is red. And the color for type DWV is yellow. Once again, you're going to look right on the side of the pipe. You should be able to see that color. And it's important that you're able to do that, because there is a difference, a very big difference, in the cost of these types of pipe, as we mentioned before, because of the wall thickness. So if you are supposed to use a type L copper on a job, but you grab a type M, well, you're not going to have a thick enough wall, and it's not going to meet the building specifications. On the other hand, if you're doing a hydronic system and you could use type M, but you grab type L, it's going to cost you way more than it needed to, because you bought the more expensive, thicker wall pipe. So you have to be able to identify this. Okay, all that said, let's jump into the sample problem. It says compute the wall thickness for K-type tube of 1 1/4 diameter. Refer to data table number 4 in the appendix. So we're going to figure out what is the wall thickness. Turns out they have all of those same dimensions on the diagram we just looked at, so you don't necessarily have to go to data table 4 for the sample problem, but you may for some of the other exercises, so keep that in mind. Let's take this step by step then. Step 1, determine the outside diameter. We look that up. It says 1.375, that's the outside of the pipe. Step 2, determine the inside diameter. We're dealing with type K, with this is 1.25 inch pipe. So we look that up and it says inside diameter is 1.245 inches. If we subtract the inside diameter from the outside diameter, we're going to get 0.13. But because that represents both sides, we're looking all the way across the diameter, we need to divide that by 2. So step 4, we divide by 2 and we get 0.065 inches is the wall thickness of type K for 1.25 pipe. With that, I will turn you loose on your exercise problems. There are 6 questions based on this short unit. You can look back over the reading if you are looking for answers, or it will also have you do a few calculations like we just did. Hopefully this helps you to understand the different types of copper. Please take the time to memorize the different types and the colors. It will help you in your career. I'll see you next time.